Our results concluded that the 75-degree angle was capable of producing the greatest distance when firing a potato. We will test this conclusion mathematically using acceleration and a vector formula in order to conclude that the results are mathematically and scientifically accurate, following the STEM model of math and science interlocking to form a conclusion. First, we will take the acceleration formula of final velocity equal to the initial velocity plus acceleration times time. For the acceleration, first we'll do the 75-degree angle. The final velocity is 0, equal to the initial velocity of 150 kilometers per hour, plus the acceleration, which is the unknown, times time of 3.0 seconds. We have to subtract the initial velocity and set that equal to the acceleration times time, divide by the time on both sides to get an acceleration equal to negative 50. For the acceleration of the 45-degree angle, we will take the final velocity of 0 plus the same initial velocity. The only variable that is changed is the time of 2.4 seconds. Subtract the initial velocity, divide by the time from the acceleration to get an acceleration equal to negative 62.5. For the acceleration of the 25-degree angle, the final velocity is 0, initial velocity 150 kilometers per hour, plus acceleration times time of 1.9 seconds. Subtract the initial velocity and divide by the time of 1.9 to get an acceleration equal to negative 78.9. Our results concluded that the 75-degree angle was capable of producing the greatest distance when firing a potato. We will test this conclusion mathematically using the vector formula now. And based upon the results from the acceleration portion of math, the lesser angles experience more rapid rates of negative acceleration. The force of gravity is increased at lower heights or angles, which leads us to conclude that the 75-degree angle would be more sufficient because of this increased rate of acceleration. The next set of calculations of each angle will help determine the ideal velocities based upon the vertical and horizontal axis. The acceleration component will be considered as well to make a final analysis upon the mathematically accurate choice of angle to achieve maximum horizontal distance. For this, we will take the 25-degree angle first. As you can see, we have the initial velocity and the angle is 25 degrees. At 25 degrees, to find the velocity on the y-axis, I must take the sine of 25 degrees equal to the initial velocity, divide by that to get 2.8 times 10 to the negative 3 as our result. And at 25 degrees, to find the velocity on the x-axis, or the horizontal velocity, I must take the cosine of 25 and divide by the initial velocity to get 6.04 times 10 to the negative 3. For the 45-degree angle, the velocity remains the same, however the angle is different. So I must take the sine of 45 divided by the initial velocity to get 4.71 times 10 to the negative 3. And at the 45-degree angle, to find the horizontal velocity, I must take the cosine of 45 and divide that by the initial velocity of 150 kilometers to get a final result of 4.71 times 10 to the negative 3. As you can see, these both are the same. For the 75-degree angle, we must find the vertical velocity on the y-axis. To do this, I must take the sine of 75 degrees and divide by the initial velocity of 150 to get 6.43 times 10 to the negative 3. And at 75 degrees, to find the horizontal velocity, I must take the cosine of 75 degrees, divide that by the initial velocity of 150 kilometers per hour to get 1.72 times 10 to the negative 3. The greatest vector for the y vertical axis occurred on the 75-degree angle. It was moderately windy on the day of occurrence, so we believe that the wind played a crucial role in allowing the potato to travel as far as it went, based on the vertical speed instead of the horizontal. Otherwise, the 45-degree angle would have produced the best shot under ideal conditions, because the y and x-axis had the same vector, thus balancing out and maximizing the distance. The test was conducted multiple times in the same location to produce as accurate results as possible. However, the conditions of freezing temperatures and winds may have swayed the results from their mathematical components. Mathematically speaking, the greatest distance produced should have derived from the 45-degree angle, not the 75-degree angle.